Welcome to Unit 3, Day 7. This is the first of two lessons about finding the roots of a quadratic function. And we'll start with finding the roots if we are in factored form. So you've got an example here. And remember that a root is very simply an x value that will make the whole thing equal 0. And so the first thing you'll do is replace f of x with a 0. Once you realize that you have two factors, you probably recall the zero product property, which tells us that if this times this equals 0, then really there's only two possibilities. Either this first factor is going to equal 0, or this second factor will equal 0. So to solve it, it's quite simple. You take each factor separately, and you set it equal to 0. And when you solve for x, for example, here I'll add 9 to both sides and then divide by 3. You will end up with two numbers. And these two numbers are your roots. Now, how do you know that they're roots? Well, not just because I can solve, but because if I plug these numbers in, the original function will equal 0. So to truly explain, or even just to check that these are the roots, we would just plug them back in. In function notation, I'm going to write f of 3, which means that I am plugging 3 into the function. And that would just mean that I'm multiplying 3 times 3 and subtracting 9. And then I'm putting 3 into the second factor as well. And this becomes 9 minus 9, which is 0, times 3 plus 1, which is 4. And that equals 0, which means, sure enough, 3 is a root. I can check negative 1 similarly by plugging it in. And we do plug it into the whole function because that's what we're evaluating. But you realize pretty quickly that the first factor doesn't matter as long as the second factor equals 0. So 3 times negative 1 is negative 3. Negative 3 minus 9 is negative 12. And negative 12 times 0, again, equals 0. To write your answer, you will just write both x values. The roots are x equals 3 and x equals negative 1 because both x values make the function's output, or you could say y value if you like, equal 0. This is quite a simple process, just splitting and solving. But one word of warning is that if you are going to split it like this, you need to have it in factored form first, which you won't always have. Take a look at the two practice problems right below. If you've solved these out, continue in this video to see the answers. If not, you might want to pause before continuing. Here are the answers. And in the practice problem, I asked you a second question, which is, what else do you know? Keeping in mind that this is not a separate skill, but it's related to what we've done before, you might have realized that you can simply turn this into standard form just by fooling out this equation. And once you have standard form, there's a whole bunch of other information, starting with the vertex, but you could even really tell me the range and the line of symmetry. You could maybe even create a graph based on all of this information, which all just came from the original function. The second example you will have noticed is slightly different because it doesn't start in factored form, so I use the snowflake method to convert it to factored form, and from there the rest of the work is just like the work above. This skill is related to another skill, which is really almost the same thing except that the instructions sometimes look a little different. Here the instructions say find the roots. Well, sometimes instead of find the roots, what the instructions on a question will say is solve this equation, and solve for x in particular is what we'll see. The only thing that is different when you're solving an equation is you need to make sure that you have a 0 on one side. Otherwise, the zero product property won't work. So for example, here I notice that I have a quadratic equation, but there's an equal sign in the middle. So before I start factoring, I'm going to switch both of these terms over. The real way to do that is to add 5x on both sides and to subtract 6. Ultimately, my quadratic equation will become x squared plus 5x minus 6 equals 0. Notice a couple things. One is that I put my 5x in the middle, and that's because I want this to look like a, b, and c, the normal standard form equation. Also notice that really what happened with these terms is they just changed sign. So if you want to take the shortcut of changing the sign as you move it across the equals, that's okay. Just be real careful that you keep track of what gets flipped when you move it in different directions. From here, I can see that this is a quadratic equation that I can factor. I find two numbers that add to 5 and multiply to equal negative 6. Okay? And those numbers are positive 6 and negative 1. And then once I have my equation in factored form, I split this equation into two pieces, which give me my roots, or in this case we would call them solutions, which are negative 6 and positive 1. Pause the video here and take a minute to look at the example to the side that says for you. And then when you're ready to continue, I'll show you the answers. Here's the answer to the one at the side. The last thing I'll show you before you go on to the practice at the back is just that there are two special cases, and they're really not different, but they might seem different, and I wouldn't want you to be fazed by them. So the two special things that can happen is that sometimes when you get your quadratic equation, there is no constant. So for example here, when I went to get 0 on one side, my constant term disappeared. This is still a factoring problem, although instead of factoring with snowflake or just in your head with parentheses, you will take out a GCF. And the only key thing to remember is that even though this doesn't have parentheses, it's still a factor, and it still becomes the source of a root. So I still set it equal to 0, and when I divide by 2 on both sides, x equals 0 is a solution, as is positive 4. The second example, again, you could factor. If you factored this, you would get 0 on one side, and then you would end up with a difference of squares pattern, plus 9 minus 9, which give you your solutions. Alternately, you could solve this using a square root, and that's a strategy we'll spend more time on tomorrow. But what you would do is you would add this constant over so that you get x squared equals 81, and then taking the square root of both sides would be 9 and negative 9. If you were in class, you will remember that there was a typo in the notes here where I just changed the problem to be a negative 4, so don't get confused by that if you're just looking at this for the first time now. Pause the video here to do the practice problems on the last page, and then when you press play again, I'll be ready to show you the answers. There's 1 and 2. For the last two equations, not only did I find the roots, but I also went on to show you all the other information that you could put together just on the basis of this original equation. When I turn it into factored form, it tells me the roots, which are these 2 points. But I could also use standard form that I started with to find the vertex on the basis of that equation for h and plugging in, which tell me these 2 points are zeros, but the vertex of 3, 1 tells me the line of symmetry in the range. Remember that the parabola faces up because the a value is positive. For the second one, you probably use snowflake in order to create your factored form. One word of warning is that I would take out a negative as a GCF before you do your snowflake. It'll make the whole process a little easier.